Alright, so for this video we're going to be talking about something that's new to my pre-calc class, something we didn't get to before this break, so that's graphing ellipses. And we're going to just start with kind of the properties of it, the basics, what makes it an ellipses, the different parts for this. Since it's new, you'll definitely want to make sure you're paying attention, rewinding, and going back if something doesn't make sense, and asking questions if need be. So the first thing is we need to show what an ellipses is. So like a circle, it has a similar formula, but it's off just a little bit. So if I look at this shape, I'm on Desmos right now graphing here. You see it's basically what you would basically commonly say as a oval, but we can talk about the different pieces that makes up something like this, or if I turn that one off for a second, something like this on its side, and we'll kind of show the differences. So similar to a circle, we have a like base version of the equation of an ellipse, but there's actually kind of two different variations here. If you notice, it's just the A and the B values get flip-flopped. What those values do, they basically tell you how far in each direction the pieces of the oval get stretched out. And A is always going to be the bigger value, and B is always going to be the smaller value. That's basically it. So when the bigger value, A, let's turn this on here. Yeah, when the bigger value, A, is underneath the X, it's stretched in the X direction. So if you think about what 2 squared is, that'd be 4. This is 16, so this one's bigger. It gets stretched further in the X direction this way. However, if the number underneath Y is bigger, like this one, so this would be 16, 4 squared, bigger than that one, stretched in the Y direction. So that's really the only difference between those two variations, is what if it kind of stands up and down or if it lays on its side. Let's go ahead and look at one for a second. Let's go with the purple one. I just prefer purple. Couple different pieces we'll be talking about. First off, we'll have the center. So that's just like a circle. You have a center to an ellipse. So that would be right here in this case. It would be the point 0, 0 unless something gets shifted. To shift it around, you would add or subtract with X or Y here. We'll look at that. We'll actually go through an IXL in a second and we'll show you that. But basically if I did let's move the square to the outside. Ooh, that's crazy. +1, this goes over to the left when it's +1. It goes over 1. So we'll talk about that more, like I said, on the IXL. Okay, so that's back to normal. So that is the center. Maybe I can label it here. Center. Yeah, that's not too bad. We also have vertices, so kind of like a parabola. Those would be on the stretched end, so on here and here, when it's laying on its side like this, so right there and right there are the vertices. Let's label those as well. So those are vertices. How you would find those, if you notice these sit at 4 and -4, well, the reason is the A value here, so if you square rooted the 16, would be 4, so it's just the negative version and the positive version. If we look at this one instead, the green one, now the vertices would be on the Y coordinate, so it'd be 0, 4 and 0, -4. And again, because this is a video and not in class, you can go back, rewind, slow down, whatever you need to do to make sense of this. Going off of vertices, we also have like the flattened side. Those do get names, and that would be a covertice. So similar idea. So those are called the covertices, so they're just the like flattened version. So this is the main one. That's the covertice. If we were dealing with the up and down ellipse instead, they'd be flip-flopped. So if the number under the y value is smaller, the y direction gets the covertice. The one with the bigger number gets the main vertice. We also have something called, maybe I can switch colors here. Let's go with, like I said, I like purple. No, but that's the color of our graph, maybe blue. From this vertice to the other vertice here, that's what we would call the major axis. So it's from the one stretched in to the other stretched in, from one vertice to the other. So the major axis would be 8 across in this case. We can even label that too. So this is the major axis. Okay. We would also have from the covertice to the other covertice would be called the minor axis. So major is the bigger one, minor is the smaller one. And that holds true for the up and down one as well. The whole thing would get flipped, so they would change places. So major is the bigger one, minor is the smaller one. For example, minor is now 4 units long, from 2 to -2. We also have something called the foci. That's a little bit different, and that's what makes this an ellipse. Essentially what an ellipse is, well, how do I want to say this? So like a circle is an equal distance from a center point all the way around. There's 2 foci. That would be, we'll give like a rough drawing. Oops. From like here-ish and here-ish, like a little bit in from the vertices. And every point, let me change colors. Strawberry. And like every point from the foci to some point on the ellipse is going to be the same distance. So the combination of this line and this line would be the same as, let's say, this distance and that distance. So the green lines, if you added them together, their distance would be the same as the, like, I think they said that's strawberry colored lines. So that's what those do. So that's how an ellipse is formed. That's a little bit harder to wrap your head around than a circle, where you would basically be the same distance all the way around. Okay, so that's a quick intro to like what we're looking at for ellipses. So let's go to the IXL now. So I'm going to clear all this off. Remember, you can look back through this. Let's close this for a second. And now we're on IXL. The one we're going to be talking about now is P7. Go ahead and start that. Find properties of the ellipse. I got a lot of remarks from the last video that I didn't do enough examples. I showed like one of each, and it wasn't enough to pick up on like what changed what part of the problem. So the game plan for me is going to be to go all the way to like a I'm going to take 70s on this, so that, like, that's where I'll go to, and I won't skip around. Um, the graph shows an ellipse. What is the length of the major axis? So let's get back to this. I think we used blue before. So the major axis, what that tells me is I'm thinking about from the longer end to the longer end. So since it's sitting on its side like this, it's from here to here. Hopefully you guys can see that. I'll do it like twice so it's maybe a little bit bolded. Maybe go the size up. I don't know if that's going to change it. Oh, there we go. Something like that. So we would just have to figure out this length like they say. So from -6 to 6, well that's 6 on this side, 6 on that side, so I would know it would be 12. So that's what we're trying to do there. Alright, let's go back down in size, go to like 10 and clear off again. Okay, so this one wants to know what is the center. So if you notice, it's not at 0, 0 now, it's up here, but they are nice to you and they highlight it. So basically they're asking for a coordinate here. So I would think, well, in the x direction it doesn't move left or right at all, so that's 0. However, it does go up to between 4 and 6, that'd be 5. So I would know that's my coordinate there. Covertices, so this is something that we labeled previously on Desmos. Covertices are the smaller, like the squished in sides of the oval. So that's here, right there, oops, and right there. So I would basically want to give those two coordinates. So this would be 0, 3 and 0, -3. And I've already tested it. It doesn't matter what order you put the two in. So you could put the negative one first, then the positive, or vice versa. Okay. What are its vertices? So when it's just the vertice, not covertice, that's the main one, so the stretched out. So that would be right there and right there. So again, I'm giving the coordinates. So this would be 0, 8 and 0, -8. Again, it doesn't matter if you put the negative one first or not. What are the lengths of the major and the minor? Okay, so it's asking for both here. So it asks for major first. So remember, major is just the longer one. It doesn't matter left, right, up, down. Major is the bigger one. Kind of goes hand in hand with the name major and minor. So major is the bigger one, so that's here to here. That's from 10 to -4. So I think it takes, if I'm thinking to myself, it takes 10 units to get to here, another 4 would be 14. So I could say that's 14. And then minor is the short ends, so here to here. So if that's from, this would be -5 to 3. It takes 5 to get back to here, another 3 would be 8. So that's kind of how I'm thinking about that. Awesome. Okay, what is the center? Okay, so we've had one like this. It highlights it for you, so we're just figuring out the coordinate. Looks like I go from the center, left 4, and then up to, this would be 5. So I would have -4 and 5. Okay, so now we're getting into the equation part of it. The length of the major axis. So to think about that, we have to think about what our ellipse looks like. I notice that the bigger number is underneath the x. So that tells me, this might be the best way to draw one of these. It would tell me it's on its side. That's pretty close. Looks like an eyeball or something. So I need to figure out from here to here, how far across. We also talked about on Desmos that the vertices are at the unless it's shifted or something, but in this case it's not because there's nothing with the x and the y. It's the square root of this, negative and positive. So the square root of 49 is 7. So that tells me this x value, oops, oh, I'm not on this, there we go. This x value is negative 7, this one's positive 7. So I could think from here to here, 0 would be like in the middle here, it'd be 14 across. So that's how I'm getting that. Let's see if I did it right. There we go. Okay, the vertices of the ellipse. So this is pretty similar to what we just had. So again, the bigger number is under the x, so I know that it's stretched in the x direction. Let's draw our kind of ellipse shape here. It's the best I can do with these tools. So I know it's from here to here, and I want to know these coordinates. Okay, I see this number underneath. I want the square root of that. So square root of 100 is 10. So that tells me this is negative 10 and positive 10. And those are x values since it's stretched in the x direction. So I know it's 10 and negative 10. For the y coordinates, because this isn't shifted up or down or anything, these are just 0. And again, it doesn't matter if you put the negative one first or the positive, it doesn't ask for order. Okay, covertice. So if I'm thinking about the shape again for another one in a row here, the x number is bigger, so it's going to be stretched in the x direction. Something like that. But it wants covertices. So what that means is it wants that coordinate, oops, and it wants this coordinate. To find that, since it's the covertice, I'm going to go to the smaller number and take the square root of that. So the square root of 4 would be 2. And that's underneath the y, so I know that my negative 2 and my 2 go in the y spot. And again, because there's nothing here shifting it left or right, these are zeros. Okay, minor axis. So let's draw this again. If we think about it this time, the bigger number is underneath the y, so it would be up and down this time. And then minor would be from here to here across. It wants to know how far that is. So I need to figure out what this coordinate is and what that coordinate is. To do that, I'm going to think about the square root of the smaller number because it's minor. So the square root of 25 is 5, so that tells me this x value is negative 5. This is 5. If 0 is in the middle, these would be 10 apart. So the length would be 10. The center of the ellipse. Okay, this one's really nice. The center is always 0, 0 unless there's something tacked on to the x and the y to shift that up, down, left, or right. So that one's really quick. The foci. So this is one that we lightly touched on, but we didn't really talk about how to get it or anything. So first I have to think about which is bigger. So underneath the y. From here we have, essentially it's a formula. Let's write that out. The formula is the same no matter if it's x or y, it's just when you write the answer. It's going to be c squared equals, and if you notice I'm already over 70, so it's just for kind of future use, I think. A squared minus b squared. So first we need to do the bigger one minus the smaller one. This is already a squared. This is already b squared, so we don't have to do any like additional math. So I would do like 66 minus 17 and get 49. So I would say c squared equals 49. Well, if I square root both sides, I'd get c equals 7. And now to fill in my answer, because it's underneath the y value, the bigger one, these are going to be zeros in the x spot. In the y spot, because it has the bigger one, I'm going to have -7 and +7, this number. Super. Let's do this one more, since we're already past 70. Alright, vertices of the ellipse. So you notice there's something going on here now, so we'll kind of tie that in. Vertices, so I need to think about the bigger one here being 25. If I square root that, that would give me just 5. So my x values would be -5 and +5. But instead of these two things being zeros, this is going to shift it down. So when this plus is inside the parentheses, it kind of acts the opposite of what you might initially think. Inside the parentheses, a plus moves it down and a minus moves it up. Or if it was over here, a plus would move it left and a minus would move it right. Like I said, it's kind of the opposite of what you might typically think. So if they're going from 0 down 8, they would then be at -8 for this coordinate. Okay, so similar thing here. Well, we'll do it real quick to get to an 80. The x value doesn't change at all, so it's at 0 for the center. But this is going to move up 4, so that would take me to a +4. Awesome. Okay, so hopefully this helped. It's weird introducing new stuff over video for me, but hopefully the ability to rewind, pause, slow down, go back multiple times helps out, and the fact that we did an entire like 0 through 80 score on here helps as well. Alright, let me know if you guys have questions. We will see you.